Okay, this is for the final, the notes. And I'm going over some questions that I think will come in the written tomorrow. And I know for sure that they're gonna bring one separation technique. Either you label or you have to describe the process. They'll get one limiting excess. I think they'll get one of the spontaneous reactions from the halides for the halogens. I think also they'll get one of the things from chapter 7, the what's it called? The flame test and the AgNO3 test, where you might have to write the reaction. المهم أنا I'm just gonna go over what I think will come written. I'll start here. CQD6, this is in chapter 6 notes. How would you obtain dry sand from a mixture and dry salt from a mixture of salt and sand? You have to describe the process, okay? This came last year in the written. Okay, if you want to get the dry sand and dry salt from a mixture of sand and salt, so you have sand and salt mixed. أول شيء you're gonna want to add water, right? Because you need to dissolve the salt. So you have to add water and you have to stir. From what from what my chemistry teacher told me, if you just say add water, you're probably gonna get it wrong. You have to say add water to dissolve the salt, or add water and stir to dissolve the salt. Just make sure to write the dissolving part. Okay, that's really important. Okay, add water and then stir. Say stir also. After stirring, you want to remove the salt, the sand now. Yeah, we say perform filtration to separate the sand, and say the sand will be the residue left on the filter paper, because we have the salt and sand mixture, right? It's the water, it has salt and it has sand. Yeah, we pour it now in the filter paper. It's like this. Yeah, the sand is gonna stay here as the residue, and then the salt water is gonna go down. So you have to say after that, perform filtration, and then you say the sand will be left as the residue, and شو اسمه, the salt and water will go down. Just try and describe the process as much as you can. After that, we want to now evaporate. We want to evaporate the salt, right? We're left now with salt and water. Salt water. How would we separate that? We want to evaporate the salt by doing crystallization. So you say put it in an evaporating dish. You have to say evaporating dish for crystallization to obtain what? The dry salt. These are the keywords. You have to now put it in an evaporating dish for crystallization to obtain the dry salt. That's it. Part B, I think maybe they'll get you part B صراحة. Uh, Sugar dissolves in water and alcohol, and salt dissolves in water but not in alcohol. How would you separate salt and sugar? So they said sugar dissolves in water and alcohol, but salt only dissolves in water. So what would you do? أول شيء we would add alcohol. This is called selective solubility, by the way. Since sugar dissolves in both, but salt only dissolves in one, we're going to add alcohol. So what's going to happen once we add alcohol? Obviously, we have to add alcohol and stir to dissolve what? The sugar, right? So we say add excess alcohol to dissolve the sugar. We have to stir, so we dissolve the sugar. For now, once we add the alcohol, this is alcohol here. The sugar is going to dissolve, but the salt will be left. Okay, what we do that? Now we can filter out the salt. So we take this, we pour it into the filter paper. The salt is going to stay here since it's not dissolved, and the alcohol and the sugar will be the filtrate. For the salt will be the residue, and the alcohol and the sugar will be the filtrate. So filter the mixture to separate the salt and allow the salt residue to dry. I don't know why to dry. What do they want? Yeah, to dry. Yeah, allow the salt residue to dry so you can take the salt خلاص and put it on the side. Gently and safely heat the solution to crystallize, but you have to mention using an electric heater. Okay, you have to say using an electric heater because uh, alcohol is flammable. Okay, so gently, so say then after we get this alcohol and sugar, we want to separate this sugar, right? So we have to do crystallization. So we have to heat it up, right? We say heat it up using an electric heater to crystallize the sugar. That's it. CQD7 I'm just gonna go through the ones I think are important. This came in term 1 final. أكيد either on a water bath or electrically because they're saying alcohol since it's flammable. Uh, or sublimes solid to gas without passing through the liquid. This is easy. These are easy. Okay, yeah, this one might come. Name all the apparatus needed to perform a distillation. Okay, the distillation. I want to see. Is it here somewhere? I don't know why it's not here. Okay, the apparatus isn't here. بس المهم. Uh, okay, first so you can understand better. What do we need for distillation? Obviously, we need a heater. Okay, we need the round bottom flask. This is the round bottom flask. Okay, we need a thermometer, and we need the condenser, and then we need the collecting flask. Okay, so it's five things: the heater, the round bottom flask, the thermometer, the condenser, and the receiving flask. And also you can say stand. I think stand is included. Yeah, the condenser, the round bottom flask, the thermometer, the Bunsen burner, and the stand. They didn't say collecting flask. Okay, no need for the collecting flask. But condenser, the round bottom, so the condenser, the round bottom flask, the heater, the thermometer, and the stand. Don't know why they said no need for. المهم, I think because they said round bottom flask, they called both of these round bottom. I don't know. المهم, what's the liquid collected? You know, it's distillate. Everybody knows this. When do we use a fractional distillation? Fractional distillation, we use it when two liquids have close boiling points. Okay, what is a fractionating column? It's a long column filled with obstacles and cooled only by air. That's important, okay? Cooled only by air. And did they say examples? They didn't say examples. But okay, quite rich in the most volatile liquid. And okay, whatever. Uh, when do we use a separating funnel to separate two immiscible liquids like water and oil? Say immiscible. Immiscible meaning they don't dissolve. Uh, after that, خلاص. I think, yeah. This comes always in the periodic in the computer. I always see this question. Uh, this also comes in the periodic. حتى if you have this photo in the periodic in the computer, you can just copy it from here if you have it in the written. You see the round bottom flask, the condenser, the thermometer, the heater, and the stand. Okay, يعني this question always comes in the periodic. I think we're done from chapter بعد في limiting excess. Okay, let me go down to the limiting excess. Where is it? Ah, one thing I forgot to mention. They might ask to write the predominant and stuff. The predominant reaction and the overall ionic and the overall non-ionic. They might ask to bring it. Make sure you know it just in case. We'll do this on CQD20. Yeah, let me copy this here. Yeah, for part A, they're saying, okay. Part A, they're saying rewrite the reaction showing the predominant. So we have calcium carbonate, calcium chloride, and potassium carbonate. They're mixing here. They wrote it as the overall ionic, the potassium carbonate, calcium chloride to produce a precipitate, the solid calcium carbonate, and potassium and chloride. They want the predominant reacting only. The predominant, you take the precipitate, you write an arrow like this, and then you see, how did I get CaCO3? It was Ca2 plus CO3 2 minus. أكيد aqueous. Is that correct? Yes. Okay. Part B. 0.5 liters of 0.4 molar concentration CaCl2 is mixed with 1 liter of 0.2 molar K2CO3. CaCO3 has negligible solubility. Calculate the concentration of all ions present when precipitation stops. Anna, I told you when you have negligible solubility or precipitation, that means they're asking for LR, ER. Okay, it's a limiting excess. Some people in the written we had last time, they didn't know it was a limiting excess question. But whenever you see precipitation or negligible solubility, that means it's a limiting excess. Okay, I'm gonna give you the easy version, step by step. I'm not gonna talk a lot. No, I'll be straight to the point. How do you solve limiting excess? What's the first step? The first step is dissociate each one, right? Dissociate each compound to find the moles. Okay, to find the moles. So what do we have? We have K2CO3 and we have CaCO3, right? فيو write K2CO3 dissociates to شو اسمه K plus and CO3 2 minus. It's 2K plus because it's 2 2, and then you have C. Why did I put K2CO3 now? Yeah, K2CO3, and then hold up. Yeah, K2CO3, not CaCO3. CaCO3 is the precipitate. I don't care about the precipitate. I'm only looking at the two before the precipitation. We need to find the moles of the compounds before the precipitation. Yeah, so K2CO3 and CaCl2. CaCl2 for Ca2 plus 2Cl minus. I balanced already, huh? 2Cl, so I put 2C here. Okay, no need. I don't know if you need the state symbols. I don't think they deducted for this part. But write it in case. It's always aqueous. Always aqueous. Okay. And these are also aqueous because they're solutions, huh? They said solutions. المهم, that doesn't really matter. What matters is the moles. They gave you the volume, they gave you the concentration of CaCl2, yeah? So can I find the moles? N equals Cv. Okay? N equals C. Find the moles for each compound, yeah? Let's see. CaCl2 is 0.5 times 0.4, which is, I think, 0.2. Should be 0.2. 0.2 moles. Type. This one here is also going to be 0.2. But this one has 2 as its coefficient. For what do? We multiply by 2. It will be 0.4. Here, K2CO3. It's 1 liter of 0.2 moles. Again, to find the moles, N equals Cv. The volume is 1 and the concentration is 0.2. 1 times 0.2, 0.2. Here, it's multiplied by 2 because since the coefficient is 2 for 0.4. Since 0.2 times 2 is 0.4. This one's normal, so we keep it 0.2. So we found the moles now for each one. Next is to find the limiting. Okay, find the limiting. How do we find the limiting? Remember in part A, we found the predominant reaction. We said it was Ca2 plus aqueous plus CO3 2 minus aqueous to produce CaCO3. This is from part A. I don't know why I erased it. Okay. Step 2 now is to find the limiting. Yeah. How do we find the limiting? It's N over coefficient. So let's see. We found we got the precipitate. We have to now do N over coefficient for these two. So let's see. We have to. This is called the ratio, by the way. Huh? What's the ratio for Ca2 plus? The moles of Ca2 plus, which is where was it? Over here, 0.2. This is why you have to do this step because you need the moles. 0.2 over the coefficient, which is 1. How about CO3 2 minus? The ratio of CO3 2 minus. The moles of CO3 2 minus, which is 0.2, over the coefficient, which is 1. If you realize they're both equal, that means there's no limiting. Okay, there's no limiting, meaning that the concentration of both of them is 0. Why? Let me show you why. Wait, just let me write it. CO3 2 minus equals 0. Why? Because they both got fully used up. Okay, if there's no limiting, that means this got used up and this got used up. Okay, هلا to find the concentration of the rest, usually we would cross multiply with the limiting. Since there's no limiting, you can take either one of these. Okay, since you can take either one of these. Wait, no, what should cross multiply with? That's different. My bad. Then to find the rest of the concentrations, we want now the concentration of K, and we want the concentration of Cl. These are the spectator ions, right? The spectators that didn't take part in the precipitation, the ones that stayed on the side. You see them? Okay. What's the concentration of K? It's going to be C equals N over V, right? V total. The moles of K, which is, we found 0.4, over the total volume, which is 0.5 liters plus 1 liter, which is 1.5. Let me move this to the right. 0.4 over 1.5. Which is, let me do it on my calculator. 0.4 divided by 1.5. 0.267. I think 0.267. And you have to put the unit. They deducted marks for significant figures in the last periodic. Please don't be stupid and put the wrong significant figures. It's very simple. Just take the least. In this case, it's two significant figures because 0.50 is my least number of significant figures. But here I'm not allowed to write 0.267. I put 0.27 because 0.267 rounded to 2 becomes 0.27. Okay, how about CL minus? CL minus is 0.4 also. For N over V total, which is 0.4 over again 1.5, which is again 0.27 m. These are my answers. Uh, that's for part B. Let me see if it's correct. Wait. Uh, yeah, they got the same answer. They got 0.267, 0.267, but it should be 0.27. They didn't ask for the mass of the precipitate, but they still found it. I'll do it now. I'll do it. And then they said concentration of the limitings are negligible. You can put zero, you can put negligible. It doesn't matter. What's this? Uh, for the mass of the precipitate, you have to cross multiply with the limiting. Uh, Many times I told you to find the mass of the precipitate, we want, in this case, it's the mass of K2CO3, right? The mass of, yeah, the mass of, can you hear me? Yeah, the mass of K2CO3. In this case, we have to cross multiply with the limiting. And let's go back to our predominant reaction. The limiting we said are both. It doesn't really matter which one you use. We have Ca2 plus plus CO32 minus. For this part, you don't have to write state symbols because you're just using it to cross multiply CaCO3, which is salt. Okay, that's shitty handwriting. Wait, let me fix that. CaCO3 salt. Okay, you want to cross multiply for RR and GR. نحن we have the moles of the limiting, which is 1 in the reaction, and which given we got 0.2, right? CO32 minus 0.2. Type the mass of CaCO3 from the periodic table. Uh, I'll just get it from Google because molar mass of CaCO3. I, what? Where's my internet? Hold up. Okay, the internet's back. It's 100. For CaCO3 is 100. For the GR, we don't know what it is. X. Cross multiply, you get X equals 20 grams. Okay, again, two significant figures. Okay, 20 grams. Then for part C, they just did it, but they just changed this to 1 liter. Same exact steps, but you're actually going to have an LR now. Same thing. I'm not going to bother doing it because it's the same thing. They just changed the 1 liter. But this is very important. LRGR, LRER. Please make sure you know it. It's going to come written. Akid. Let's move to chapter 7 notes. Um, for chapter 7, I think they're going to get the spontaneous, non-spontaneous reactions, which is here. Yeah. Before moving on to that, this wasn't in the quiz, but let me just, well, what am I saying? Let me just, go over it quickly. Iodine is dark gray solid that sublimes into purple fumes. Okay, iodine is a solid. It's dark gray. You have to know also the state for the halogens, if you remember. Helium is the least dense, unreactive gas. Okay, since it's a noble gas, it's unreactive. But if you want the least dense in general, it's hydrogen. Okay, hydrogen is the least dense reactive gas. Least dense alkaline metal is lithium because it's all the way at the top. Li is the first alkaline metal. Nitrogen is a diatomic element that constitutes most of air. Oxygen is diatomic that's needed for breathing. I think maybe they get this. I don't know. Just in case, I think they'll get this صراحة. بحسهم بيجوها. But let's go over what's this? Complete imbalance. If no reaction takes place, right? No huh? Yeah, I found this. Okay, I was here. Uh, yeah, I found this. By the all the solutions for these questions of the notes are in the course revision solutions. Huh? Uh, how it goes is they're saying, is there a reaction taking place? Ki and AgNO3. AgNO3 is, it's used to test for the halide ions, right? Which are FCl. Wait, hold up. No, no, no. AgNO3 is used to test for, remember the three halide ions, which were uh, chlorine, bromine, and iodine. Remember, for chlorine, it will become white. For bromine, it will become creamy. And for iodine, it will become yellow. Okay. ف is there a reaction with if you have any AgNO3 and iodine? Of course there will be. Remember the reaction was Ag plus I plus the the halide to produce uh, a precipitate AgI solid. Let me see. Is that the solution? Ag ugh, 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 ugh. Okay, well yeah, you get AgI, right? You're gonna get AgI, but they want to know what's the product at the end of this. They're saying this is the reaction. They want the product. Tab Ag and I, because we said that's the AgNO3. When you add it to iodine, you get AgI. But they want to also know the rest. What are you left with? You're also left with KNO3. That's it. No. Ag and I mix, and then KNO3. I think that's it. Yeah. Okay. It's because Ag will mix with iodine and become AgI, which is yellow, and then you're gonna be left with KNO3. Okay, Br2 and KCl. Okay, if you can see, this is a halogen, this is a halogen, but this is the neutral halogen, and this is the charged halogen. Okay, remember the halogens were FCl, Br, I, At. Okay, remember it has to be the neutral one, which has 2 as a subscript, has to be more reactive than the other one. Br in this case is neutral. Is it more reactive than Cl? Let's see. Is Br more reactive than Cl? No, it's not. So we say no reaction. I think a question similar to this came last year in the written. H2 plus Cl2 plus a spark hydrogen plus a halogen gets you the acid as the hydrogen, the acid halogen, 2HCl. I think plus energy. Oh no, that's it, 2HCl. Hydrogen plus chlorine, you get HCl. Everybody knows this, I think. NaF and AgNO3. Is AgNO3 used to test for fluorine? No, for no reaction. Cl2 and Li, lithium iodide, and Cl2. Uh, you have two halogens, Cl and iodine. Is chlorine, the neutral one, chlorine, is it more reactive than iodine? Let's check. Chlorine is here, iodine is here, more reactive. So that means you will have a reaction. What is the displacement reaction, by the way, is just swapping. Okay, so you're gonna get LiCl. Hold up, that's not right. You're gonna get LiCl plus 2I. So you just swap the I with the Cl. That's it. And let me show you a solution. LiCl. Oh, why is it 2 LiCl? Oh, let me see. Is this balanced? LiC. Oh, no, no. You need to put the 2 here. Okay, you need to put the 2 here. But that wouldn't make it balanced, was it? 2 LiCl. But that means 2. This is wrong. This is definitely wrong. You get I don't know why they put the 2 here. You shouldn't. Well, akid you should because you have 2 chlorines. Balancing that you should just put the 2 here also. Uh, is it balanced not 2 Li, 2 yeah. Yeah, you should put the 2 here also. I don't know why you should put the 2 here. But they're just trying to balance. But my point is, for displacement reactions, you just swap. So it becomes LiCl plus I2. And then you balance. Since there's 2 Cl's, you have to put the 2 here. Now since there's 2 Li's, you have to put the 2 here. And now it's balanced. H2 plus K, any hydrogen plus alkali metal. Remember, it was the alkali hydride, so it will be KH. And then balance it 2H if you put 2 here, and then 2K if you put 2 here. Okay, that's it. 2K. I think this is a gas. Is it a gas? No, I think it's a solid actually. Yeah, solid because it's ionic. NaH plus H2O liquid. Remember, if you have any alkali hydride dissolved in water, all you're going to get is hydrogen gas. Plus, you're going to get the alkali hydroxide. Remember, always the alkali OH, which is aqueous. Aqueous and hydrogen. No, it should be gas. definitely should be gas. I know that's wrong, 100%. Uh, HCl plus NaOH. Here you have, okay, what's gonna happen? You're gonna get NaCl plus H2O. What's this? Whenever you're mixing an acid with a base, okay, acid with a base, this is an acid, this is a base, you're gonna get a precipitate, which in this case is NaCl, okay? The precipitate is the metal with the non-metal, huh? And you're gonna get, what's left over. H and OH, it's H2O, which is a liquid. That's it for these. Uh, I want to do question 26 also. Colors a flame red, okay, it should be lithium. Let me just check the solution in case أنا بخبص. Yeah, lithium. I don't know. Put the charge, okay, Li plus. Forms a cream colored precipitate with silver nitrate. If it's cream colored cream, that means it's Br minus. Blue crystals that become white powder when heated. Huh? What? Okay, we did not take this. I know we did not take this. Okay. D, a dark gray shiny element that sublimes into purple fumes. This is iodine. We said it's iodine. Its solution turns brown when Clorox and acid is added to it. This is, you could say, iodine or bromine because it was in the table. It was in the table up here, uh, somewhere here. Let me find it. In شو اسمه water يعني Clorox. Uh, remember, bromine and iodine are both brown. Okay, they're both brown. Uh, let me go back here. So when it turns brown, it's either iodine or bromine. And yeah, here. Uh, but you have to be careful since we're talking about ions. Yeah, you have to say iodide and bromide. Okay, you have to say these. Okay, you're not allowed to say or iodide. Bro, just write خلاص. It's the words. Don't write it. Just write Br minus or I minus. Okay, don't confuse yourself. I'm just gonna put I'm gonna put minus. I don't know why they put iodine. This should be IDE here because it's an ion. Uh, anyways, yeah. Anyways, let's move on to F. Just write I minus and Br minus here. Least dense unreactive gas, we said is helium. Least dense reactive is obviously hydrogen. Least dense alkali metal, we said was lithium since this was all the way at the top. And which one's the gaseous diatomic element that constitutes most of the air? Nitrogen. Yep. Okay, I think we're done here. Why does every element in group I form ions of charge +1? Because they lose an electron. Wait, let me see this. Question 21. Only one pair. Ugh, 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 ugh. Okay, it should be because they all lose an electron. What elements form ions of charge +2? Group 2 elements. What form ions of charge 3? Group 3 elements. Why don't elements of group 4 form ions of charge 4? Why do they form ions of charge 4 minus? Honestly, I don't know. I'm gonna skip this. Okay, I don't think this will come aslan. Where I can't find it. Like I'm looking for the solution. Uh, I can't find it. This was all 7.9. You don't need any of this. Okay, okay. But this isn't 7.9. This is, you need this. Okay, because it was in the notes also. I think they'll get this written صراحة. We'll do it in a second. Uh, Okay, I'm gonna skip D. Why do elements of group 6 and 7 form charge of -2 and -1 respectively? Because 6 gains 2 electrons and 7 forms gains 1. Because look, whenever you're talking about gaining electrons or losing electrons, always say to obtain the noble gas configuration. Okay, so like a group 6 element, for example, oxygen, it needs 2 electrons to obtain the noble gas configuration. Okay, how else do elements of group 6 and 7? I don't know this. In H2O, why does hydrogen make one bond while oxygen makes two? Okay, Hydrogen makes one bond because it only needs one electron to become like, it was helium, I think, or neon periodic table. The one neighboring hydrogen was helium, right? It only needs one electron to become like helium. But oxygen needs two, because it needs two to become, see, oxygen, one, two, to become like neon. Okay? Uh, for oxygen needs two to become like neon, and hydrogen needs one. How do you explain that oxygen forms O2 molecules? Oh, what do you mean explain? يا أخي انسى انسى. Don't do this. Okay, this I'll do 28. Identify the type of bonds, group 1 and group, that's, what's VI? Uh, Roman number. 6. Okay, 6. Group 6. Group 6 is a non-metal. Group 1 is a metal. Metal non-metal, you say it's a قصدي ionic. Ionic, صح? Yeah. 28 ionic. Okay. Uh, Group 6 and group 8, I think that's group 7, no, group 6, group 7, covalent because it's non-metal, non-metal. Group 2 and group 6, ionic. Group 6, شو group 6, group 7 قصدي, covalent. Group 6 again covalent. Let me make sure. Yeah. 29. Which of the following form an ionic compound? What's the question also? Uh, okay. I'll do this one. I'll do the one in the notes first. Which ones form an ionic compound? X and W. X atomic number 11 and Z is atomic number 16. But you go to the periodic table, you go atomic number 11, which is here. Then you go to which is Na. Then you go to 16, which is, I think, sulfur. Metal, non-metal. What does that mean? Ionic. And let me show you the rest. Yani X and Z. Z is, wait, no, X and W. They want X and W. Hold up. Why is X and Z? X and Z is wrong. X and W. What's X and W أصلا? 11, 7. And X and Z. Wait a minute. X is 11. Look, part A, X and W is correct. X, wait, I will see them. Let's identify all of these. Atomic number 11 is Na. 14 is, I think, what's 14? Silicon. Okay. Z is, I think, sulfur. 16, sulfur. I put S. Yeah, I put S. And W is nitrogen. X and W, okay, X is sodium, W is nitrogen. Metal, non-metal should get you an ionic compound. X and Z, sodium and sulfur. Sulfur is, it's a non-metal, right? Sulfur, S, yeah, non-metal. It should also form an ionic compound. Y and Z, it's silicon and sulfur. Obviously not, because they're non-metal, non-metal, okay? Y and W, Y 14 and W again non-metal, non-metal for no. Z and W, sulfur and nitrogen, they're also both non-metals, so you can't. I would argue that B is also correct. X and Z. Does sodium form an ionic compound with sulfur? Yeah. it forms an ionic compound. أصلا يا أخي it does. Look, wait. Like it's an exception. Oh, maybe it's an exception. Wait. What's this? What's this? Huh? Uh, 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 uh. I think this is from this. X and W. X and W, we said. Uh, I think this is part of a different section. Because there's this whole table. But I don't think you need this صراحة. To do the X and Z. X and Z, we said it was sodium and uh, sulfur, right? Uh, they're saying covalent. I don't know if that's for oxygen or obviously water is covalent. يخي. With sodium. No, it should be ionic. It should be ionic. I'm telling you, it should be ionic. Okay. Uh, Na2S. I'm just making sure in case I'm tweaking. Uh, yeah, I'm not tweaking. It's correct. Okay, it should be A and B. Okay, question 31. Alright, let's do this. Uh, X combines with W to form an ionic compound, X2W. Okay, X is obviously hydrogen, yeah? Okay, well, you don't need to know asla. But X is in group 1, okay? So it's whatever, X plus is gonna be plus. And then W is group 6, so that means it's 2 minus, yeah? For W, 2 minus. For what's it gonna be? Cross cross, you're gonna get X2W. Z has 2 electrons in its outermost shell. Z is in group 2, فأكيد it has 2 electrons. Y combines with W to form a covalent compound YW2. Y is group 1, 2, 3, 4. Okay, that's I think Y is silicon, right? It's okay. Hold up. Uh, ugh, it's correct. Okay, this I think came also. Y Y SiY2. Yeah, Y was silicon. It's Si, and this came in the periodic aslan. Uh, it's in group 4. Okay, any group 4 element with I think the group 6 elements they form YW2. Like for example, if you want to look at carbon, okay, carbon with oxygen CO2, Si with oxygen SiO2. I don't know about the rest. Uh, but yeah. Uh, when they combine with oxygen, it's always the group 4 element with the group 6 too, if you get what I mean. For this Y, it's in group 4. When it's combining with this W, with this, which is oxygen, it's obviously oxygen. Okay, it becomes uh, YW2. Also, this is carbon, huh? Y is carbon. It's at the top. If you have a periodic table, you can solve this easy. If you go just to the periodic table, it's carbon, it's oxygen. Everybody knows it's CO2. You know, carbon dioxide. Uh, I think these are really easy. You just need a periodic table. Z has more metallic character than X. Why? No way that's true. Is it? It is. Ah, Z has more metallic character than X. Okay, apparently yes. Group 2, I googled it. Group 2 is more metallic than group 1. I don't know why. They said there's more metallic bonds, but okay, just memorize it, I guess. Group 2 is more metallic than group 1. Okay, W is a group 6 element in the periodic table. Obviously, this is group 6, 7, 8. W is group 7. As a group 6. Ya Allah. And then from the notes, question 31. Didn't we just do this? Yeah, we just did. Okay, yeah, we just did. Uh, I think, wait, does that mean the solutions for this are here? No, they're not. Okay, I mean, other than this, I can't think of anything that could come. Maybe this could come. Wait, let me go back to the notes. Uh, AG, where's the AG? Uh, 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 displacements. They're just talking about displacement reaction. Okay, I don't think this matters. This shouldn't matter. But what you have to know is, yani, does the reaction occur or does it not? Okay, that's important to know if the reaction occurs or not. Like, yeah, here, NABR, you have to, like, this is important. Okay, or maybe uh, I2 cannot display. Yeah, okay, they're just explaining it still. I think this is the one I want. This was in the quiz, no? Okay, yeah. this was in the quiz, but I'm still gonna solve it because of the part where they say write balanced chemical equations when possible. I think they might get this because even our chemistry teacher did talk about something like this coming. Okay, uh, أكيد it's obvious. Oh, that's too big. It's obvious إنه the flame test and the AgNO3 test, you can know what the elements are. They're saying it became brown, so it's either Br or I. Then they said when they added CCl4, it became purple violet, so that means it's I. When a platinum wire was dipped and put into flame, became violet. That's K. Okay, it's obviously Ki. Yeah. But here's the part where they say write balanced chemical equations whenever possible. For let's start with the I. Yeah. You know AgNO3. Yeah. Plus. Never mind, never mind. I'm looking at the solution. That's not what they mean by chemical equations. They want you to go through the steps of what's happening. They're saying أول شيء إنه write down the steps. أول شيء say إنه lilac color, lilac flame. That means it's K plus. And then just more. When we said it was dipped in water to become brown, dipped in water to be brown, you say either Br minus or I minus. Then you say uh, it turned purple in CCl4. In CCl4, that means it's I minus. Okay, so then what do they say? Uh, M is potassium. Yeah, then you say خلاص, it is potassium iodide. And then you say Ki. Okay, you just have to describe the whole process. Then for this last part, they're saying Ki became K plus and I minus. Why? Because look at the question. They're saying that we're dissolving the solid in an aqueous solution. Okay, and يعني once we dissolved it in this aqueous solution, uh, it's separated into ions. If you get what I mean. Why am I saying it's separated into ions? No, look, we added the chlorine water. Okay, it became brown. That means you got the ion minus ion, and then we added CCl4. It's purple violet. So it got separated into ions. It got dissolved. So the first balanced reaction you write is Ki, which is the solid. It got dissolved into K plus and I minus, which are both aqueous. Okay, aqueous and aqueous. How long is this? For a good 2 hours at least. Oh, 43 only. Okay, and then the second thing you're gonna write, since we're adding chlorine water, that's Cl minus, yeah? That means there's a displacement reaction going on. Okay, what's a displacement reaction going on? We have this chlorine, right? The Clorox or the chlorine. So the displacement reaction goes from the more reactive to the less reactive. So we have the Cl and we have the I. Which one's more reactive? Remember, you have FCl, I, and then AT. Okay, Cl is more reactive than Br, as they than I. Cl is more reactive than I. What do you do? How would you write the displacement reaction for that? You're going to say Cl2 aqueous, obviously, plus 2I minus aqueous to produce, now swap them, 2I2, as they, sorry, yeah, I2 aqueous plus 2Cl minus aqueous. That's it. Uh, I think that's in the solution. Yeah. Okay. Why did I write this? Because it was a displacement reaction. How do you know it was a displacement reaction? You're adding two halogens, Clorox and the iodine. They wouldn't just say Clorox for no reason. And I think really, if they bring this, if they bring this, they're gonna bring the same exact thing. Yani. They might change the lilac violet. Maybe they put red, but like they're gonna get the same exact way of asking the question. Uh, Maybe is there anything else I can give you guys here? I think they might ask you to write this equation, the one for the halide ions. the Ag plus and the Cl minus, Ag plus, Br minus, Agi, and Ag and I, Agi. They might ask you because really they asked it a lot in the quiz. Like let's say salt S here uh, is dissolved in water when a silver wire is dipped. Okay, in a blue flame, the color of the flame turns to bright yellow. Okay, if that means uh, it's Na. When a few drops of silver nitrate are added, a white precipitate forms. White precipitate minus it's Cl minus. Okay, which slowly turns into purple and black. Forget about this. Okay, what is S? We said you have to write. Like, let me show you. I'm not gonna write it, but you have to write. Since it's yellow flame, then Na is present. It's Na plus. Then you say white precipitate. That means Cl minus. Then you have to write the equation for how did you get this white precipitate? We're adding AgNO3, right? We're adding Ag. How do you get it? It's always Ag plus what did we have? We had Cl minus. Cl minus to produce AgCl. And a key has to be solid, aqueous, aqueous. Okay, there you go. S is sodium chloride because you got sodium and you got chloride, NaCl, key NaCl. That's it. صراحة I can't think of anything else for the written. Why did I open Spotify? Uh, thank you so much for watching and good luck.